Good afternoon, team. In this opportunity, I will be talking about the statistical test of this paper called tenofovir versus placebo to prevent perinatal transmission of hepatitis B. My name is Gabriela Mateo and I belong to Group 5. So the first thing that we should do when looking at a paper is try to analyze the pickup, try to bring it forward so we can understand a little bit more about the variables. So the patients, participants in this study were pregnant women with an elevated viral load of hepatitis B virus at risk of transmitting infection to their infant. The intervention was this medication tenofovir, this procil fumarate, and it was compared with placebo to look for an outcome in hepatitis B surface antigen positive status in the infant, confirmed by the hepatitis B virus DNA level, and this was going to be confirmed at 6 months postpartum. And then, so the time of the intervention really was running after 28 weeks of pregnancy of the patients up to 6 months postpartum. However, they didn't really specify, like the average amount of weeks that the pregnant women were in pregnancy. So, but we can just estimate that the time of the study was going to run up to 6 months postpartum, from 28 weeks up to 6 months postpartum in all the women. After we're looking at pickup, we can see which ones are our variables and then we can classify them in order to choose the best summer statistical test. In this case, the primary outcome was dependent was the positive status in the infant, meaning categorical binary, because we want to see if the infant was positive or negative. So it's a yes or no. Therefore, it's categorical binary. And the independent variable was the two groups, the interventions of tenofovir versus the placebo, which is also categorical binary because it's either intervention, treatment, or no. When we're looking at these variables, we have like binary, categorical, independent, and binary, categorical, dependent variables. Then we have the choice of using chi-square or a Fisher-Test exact test. As we can see in their statistical analysis, they chose to use a Fisher exact test to look at the efficacy point. This was the primary outcome of the positive status in the infant after 6 months postpartum. But for secondary outcomes, they use a student t-test, meaning they were looking at the DNA level in the infant growth in comparison to the two groups, the binary categorical variable. And lastly, they looked at time to event of to the first adverse event after using this medication. So they use a long rank test for this. I think the statistical choice of analysis was perfect. And in the first place, choosing the Fisher exact test as opposed to the chi-square would always give a more correct exact p-value. It would always be more correct. These tests, either chi-square or Fisher exact test, they're used when the association between two or more categorical variables are assessed. And we're looking at what is the relationship between variable A and variable B. And instead of like parametric tests or tests that looks at the analysis between an outcome that is continuous, Fisher test and chi-square, they analyze the proportions of frequency within each category in each group. And they're looking at whether the difference between the observed and the expected frequencies are sufficiently large to reject the null hypothesis. We want to find a large difference between both groups to be able to reject the null hypothesis, because the null hypothesis says that both groups are equal. And usually the reason why we would choose a Fisher exact test is because it's more exact. Also, when the chi-square cannot be used when the expected frequencies are less than 1 or 20% of the expected frequencies are 5 or less. Therefore, we have to use the Fisher exact test. The only times that Fisher exact test may become cumbersome is when the expected frequencies or the observed frequencies are too large. And this is a complicated statistical test. It's good that we have, a statistical softwares that can now, give us a Fisher exact test very simple and easily. But sometimes even the statistical programs run and two caveats when they have to do like large calculations. And in this case, we will have to rely on the chi-square. But the feature exact test is always correct, which is this is why I agree it was chosen instead of the chi-square. For secondary outcomes, they chose a student t-test to compare the independent variable was categorical binary, and then the dependent variable was continuous, looking at the DNA level and also at the growth level, which are both continuous variables. And therefore, they chose a student t-test. This test is simple, is one of the most commonly statistical tests used, and it is used to compare the results between two groups that were assessed in a continuous outcome, as I just explained. It's mostly, one of the benefits of student t-test is that it's simple and to use and to understand, and that is robust to small violations in the normality assumption. Remember that for the use of parametric tests, certain assumptions have to be made. And one of these being that the variance between both groups have to be roughly equal, and that also that the distribution under the curve of both samples have to be normal. The independent variable is binary for two groups, and the dependent variable continues, as I already explained. However, when student tests have two forms, one is unpaired and one is paired. When we're looking at independent samples, two groups that are assessed on a continuous variable, completely independent of each other, then we're using unpaired t-test. But if we're using one single sample where we're doing a pre-test, post-test measurement, I mean, pre-intervention and post-intervention measurement, then in this case, we use a paired t-test. Lastly, I really agree also with them using a survival analysis to look at the time to event to the first adverse event after the medication or the placebo. And they use the long run test to analyze the curves. The survival analysis is focused on time to event, meaning how much time passes from the exposure or the intervention to the occurrence of the event that we're looking for. It compares of the survival functions. In this case, the survival functions are given by Mayer estimators, and then the long run test is used to, to compare the difference between both curves against the null hypothesis. Right? So if the null hypothesis is rejected, the survival functions are assumed to be statistically significant different, and that's what we're looking for. So I completely agree with the three choices of statistical tests chosen for the primary and secondary outcomes in the test. First, the Fisher exact test, because of looking at both independent and dependent binary categorical variables, and because the Fisher exact would always be more exact than the chi-square. And even though we had a large sample, it wasn't that large enough that it contradicted the use of Fisher exact test. For the secondary outcome of DNA level and infant growth in both groups, I also agree with the student t-test. It's robust to small violations. It's easy to understand. It's one of the most commonly used tests. And for the time to event analysis using the long run test, I think it's also a really good choice, because the Mayer estimated curve by itself would only give us the curve, and then doesn't give us really the significance, or it doesn't test the differences between both curves. Like by looking at the curves, we can see that the difference is visually, but we don't really get to test it unless we run a long run test. This was the references, and thank you very much for your attention.